Welcome to the deep dive. You can't walk a block in New York City without seeing concrete.
Everywhere. Cranes, trucks, new buildings going up.
Exactly. It's the bones of the city. And for anyone curious about how it all actually works behind the scenes.
Right, from the developer down to someone just watching it happen.
We're doing a deep dive today into something really specific to NYC construction.
Yeah, this is very much a New York thing.
The TR3 technical report and the mix design that goes with it.
That's the one. If you're building here, you will know the TR3.
So what is it exactly, in simple terms?
Okay, so it's a technical report. Yeah. Required for the concrete mix design.
Okay.
Mandated by the NYC Department of Buildings, the DOB.
Before you even get a permit.
Yeah, it's an upfront thing. Think of it as like the first quality check, ensuring the concrete itself is designed properly before anything gets poured.
Got it. So a baseline standard for the concrete.
Exactly.
Now, you mentioned a mixed design too. Is that the same thing or different?
Ah, good question. They're related, but different. So usually there's a licensed concrete testing lab. They're, approved by the DOB.
Right.
They develop the detailed mix design first. It's like their internal recipe book.
Their own document.
Yeah, very detailed. Comes from running lots of trial mixes in the lab.
Okay, so that's the mix design. What about the TR3 then?
The TR3 is the official DOB form. It's standardized, universal across the city. The lab takes the key info, the really important stuff from their detailed mix design.
And puts it onto the TR3 form.
Precisely. So the mix design is the lab's cookbook. The TR3 is the official recipe card the city needs.
Okay, that makes sense. Cookbook versus recipe card. I like that.
Yeah.
So our mission today really is to figure out who does what in this whole process.
Right. From mixing the first test batch to getting that final signature on the TR3.
Who's running the mix? Who's gathering the data? Who's putting these documents together?
Exactly. And understanding that chain of responsibility is super valuable.
For everyone involved.
Absolutely. Clients, contractors, engineers. It clarifies who's accountable for making sure that concrete is right from the start.
It's not just one person signing off and hoping for the best.
Definitely not. It's a shared responsibility.
Yeah.
A system of checks.
Okay, let's start at the beginning then, the mix design. Where does that process kick off?
It almost always starts inside a licensed and accredited concrete testing lab here in the city.
And these labs are DOB approved, you said?
Yes, they have to be. It's a rigorous process. And interestingly, these labs are often running trial mixes proactively.
What, even before a specific project needs one?
Yeah, sometimes. They experiment in a controlled lab environment to kind of build up a library of potential designs.
Like chefs testing recipes in the kitchen.
Yeah, that's a really good way to put it. They're experimenting meticulously.
With what ingredients? Just cement and water?
Oh, much more than that. Different types of cement, maybe slag or fly ash. Those are supplementary cementitious materials. Fine aggregates, sand. Coarse aggregates, stone. Gravel. Water, of course. And then chemical admixtures.
Admixtures, like special ingredients.
Exactly. Chemicals that fine-tune properties.
Yeah.
Like how easily it flows, how fast it sets, durability, that sort of thing.
Wow. So it's really a science, not just throwing stuff together.
Definitely a science. And they don't just do one mix. They run multiple trials.
To get it just right.
Optimize it. They're looking at strength, obviously. Compressive strength is key.
Right.
They test that at 7 days and critically at 28 days.
7 and 28 days. Why those times?
Well, the 7-day gives you an early idea. Lets you see if you're on the right track, maybe make adjustments for future trials.
Okay.
But the 28-day strength, that's the benchmark. That's usually what the design is based on, what confirms it meets the spec.
So 28 days is the big one.
It really is. But they're also testing other things besides just strength.
Like what?
Workability. How easy is it to place the concrete? That's measured by a slump test.
Slump test.
Air content. Very important here in New York with freezing and thawing. Air bubbles give it durability.
Ah, right. For the winters.
Exactly. And also unit weight. How heavy is the concrete per cubic foot?
So strength, slump, air, unit weight, they're juggling all those factors.
Correct. It's a balancing act, all happening in the lab, often completely unseen by the end client.
Okay, so the lab's doing this crucial groundwork. Let's talk more about their specific role. What are their responsibilities once a project actually needs a mix?
Right. So a client or contractor comes to them needing a specific mix for their job. The lab then often initiates contact with a concrete producer.
The producer, the company with the trucks, the plant.
Yeah, the ones who will actually make and deliver the large batches of concrete for the job site.
Why contact them so early?
Because the goal is to develop a mixed design that can actually be produced consistently by that specific plant.
Ah, so it's not just theoretical lab perfection. It has to be makeable in the real world.
Precisely. So the lab needs to get samples of the actual materials that plant uses.
The same cement, the same sand and stone.
Ideally, yes. Directly from the plant that's going to supply the job. Same chemicals, too. That way, the lab tests reflect what will actually be delivered.
They're basically simulating the plant's production, but in the lab.
Exactly. On a small, controlled scale. And they have certified technicians doing this.
Certified?
Yeah, ACI certified.
Right.
American Concrete Institute. Specifically, ACI field technician, grade 1 certified technicians.
Okay. What do?
They run all those tests we mentioned, slump, air, unit weight, temperature, just like they would on a job site, but in the lab's controlled setting.
So they know the standard procedures?
They have demonstrated proficiency in them, yes.
Right.
And crucially, they make the concrete test cylinders.
Ah, the cylinders. I've seen those. Little concrete tubes.
Yep. They make them according to very strict standards, then cure them carefully.
Curing, like letting them harden properly.
Exactly. Usually in a moist room or a water tank with controlled temperature. This lets the concrete gain strength correctly.
And these are the cylinders they test later for strength.
Those are the ones. They crush them in a machine at 7 days and 28 days, typically, to get the compressive strength data.
Okay, so the lab gets all this data, back strength, slump, air.
Right. And they analyze it all. They're looking for the mix that hits all the targets. The required strength, the right workability, good air content for durability, whatever the project needs.
Finding the sweet spot?
That's a good way to put it. Once they find that optimal mix, they compile everything, materials, proportions, test results, into their comprehensive mixed design document.
Their internal cookbook. Got it. So the mixed design is done. Now, back to the TR3. How does that fit in?
Okay, so the TR3, that's the official New York City Department of Buildings technical report form for the concrete mix.
Only used here.
Only in the 5 boroughs, yes. It's unique to NYC, and it's required before a permit is issued for concrete work.
Okay, so the lab has their detailed mixed design.
And they take the key information from that.
The vital stats, basically.
Exactly. The specified strength, the materials, the proportions, the water-cement ratio, slump, air content, all the critical stuff.
And they transfer that onto the standard TR3 form.
Correct. They populate the fields on the DOB's TR3 form using the data from their mixed design.
So the mixed design might have more background detail.
Oh, yeah, much more. Graphs, maybe specific test methods in detail.
But the TR3 is the official condensed summary everyone needs.
Precisely. It's the snapshot that the DOB, the engineer, the contractor, everyone relies on for the official record.
Okay. Now, this TR3 isn't just filled out by the lab, right? You mentioned signatures. Who has to sign off on this thing?
Right. This is crucial. It's a shared responsibility. Once the lab generates the mixed design and fills out the TR3, several different parties have to review it and sign it.
And this happens just once at the start of the job?
Typically, yes.
Yeah.
For that specific mixed design from that supplier, it's an upfront approval process.
Okay, so who's signing? Walk us through it.
First up, the licensed concrete testing lab itself. They're the applicant.
The ones who did the work.
Exactly. Their lab director signs in Section 4. They're certifying that the information is correct and complete, and the tests followed all the rules and regulations.
Makes sense. They stand behind their data. Who else?
The architect or the engineer of record for the project, they're called the design applicant.
The PE or RA who designed the building?
Correct. They put their professional seal and signature in Section 6.
What are they certifying?
They're stating they've reviewed the mixed design from the lab, and it complies with their approved construction documents. Basically, that this concrete mix is suitable for their design.
Okay, so the designer confirms it meets the structural needs. Got it. Next.
Section 5 is for the concrete producer.
The plant owner.
Yes, the owner of the production facility is supplying the concrete.
What do they confirm?
They certify that the specific materials listed on the TR3 are available at their plant, that they commit to using those materials for this job, and that the mix is appropriate for the site conditions and how it'll be placed.
So they're saying, yes, we can make this exact mix with these ingredients, and it'll work for this project.
That's the essence of it. Then there's the sign applicant.
Who's that usually?
Often the client or maybe the general contractor acting for them. Whoever sort of initiated the TR3 process with the lab.
Okay. And one more.
The building owner. They sign in Section 7. It's mainly an acknowledgement, understanding the penalties for falsification.
Wow. So lab, designer, producer, applicant, owner, it's quite a chain of
It
accountability.
really is. Multiple checks.
Now, the TR3 form itself, you mentioned Section 3 has a lot of the technical details.
Yes, Section 3, strength requirements and design and material type. That's where the core data for each mix goes. And you can list up to 3 mixes on one TR3 form, by the way.
Okay. What kind of data is in there?
It states how the mix proportions were determined. Was it a lab trial mix, or based on past field experience, or both? If there was a trial mix, the data is listed.
Important for traceability.
Absolutely, then you have the strength.
The FESI and FESIR.
Exactly.
Yeah.
The specified strength, FVRE, which is the target strength the designer wants,
Yeah.
and the required strength, FESER, which is usually a bit higher to account for variability.
Right. And the age for that strength.
Yes, a specified test age, usually 28 days for most concrete.
What about the ingredients? Are they listed?
Oh yes, in detail. Material type and source for everything.
Yeah.
Cement type, any slag or fly ash.
Yes.
Source of the sand, fine aggregate. Source and sizes of the stone, coarse aggregates.
Yeah.
Plus their ASTM standard numbers.
ASTM.
American Society for Testing of Materials.
Yeah.
Industry standards for quality.
Gotcha. What else? Water, admixtures.
Yep. Amount of water, usually gallons per cubic yard. And all the chemical admixtures listed by type and dosage, like ounces per 100 pounds of cement material.
So you see the whole recipe.
Pretty much.
Yeah.
And also the water-cement ratio, actually. Water to cementitious materials ratio, technically. Very important for strength and durability.
Okay. What else is on there? Slump, air.
Yes. Target slump or spread, depending on the concrete type, with its tolerance range.
Yeah.
That tells you about workability.
Ah.
Air content, again, with a tolerance.
Mhm.
Crucial for freeze-thaw resistance, like we said.
Right.
And the design unit weight, usually pounds per cubic foot.
That is a lot of critical info packed onto one form.
It really is a dense snapshot of the mix.
So once this TR3 is filled out, everyone signs it, it gets submitted to the DOB. What happens then? Is it done?
Once the DOB approves it, that TR3 is generally good for the whole project.
For that specific mix and supplier.
Correct. You don't usually need to redo it unless the mix design itself changes significantly or you switch concrete suppliers mid-project.
So it's not like, say, the TR2 form, which I understand is related to testing during the actual pours.
Exactly. That's a key difference. The TR2 involves ongoing inspections and testing during construction.
Yeah.
The TR3 is the upfront approval of the mix design.
But you still need the TR3 later on, right?
Yeah.
Even after it's approved.
Absolutely essential. The contractor or client has to have that approved TR3 available on site.
Why? Who needs to see it?
Well, for instance, when the inspectors from the TR2 testing lab show up during a concrete pour,
Ah, the inspector's doing the on-site testing.
right, they need to see the approved TR3
To check what, exactly?
to verify that the concrete being delivered by the truck actually matches the specifications on the approved TR3.
So they're comparing the delivery ticket and maybe doing quick field tests against the approved design?
Precisely. They're checking slumps, air content, temperature, making sure it aligns with the TR3 ranges. It ensures the client is getting the concrete they paid for, the one that was approved.
It all connects. The initial design approval links directly to the quality control during the pour.
That's the system.
Now, we've mentioned the field inspectors for TR2 and the lab techs doing the strength testing. Are there other certified people involved earlier in the mix design stage? Seems like a lot goes into it.
Yes, definitely. It's not just the field grade 1 techs making cylinders.
Who else?
You have aggregate testing technicians, often certified to ACI Lab Level 2.
What do they do?
They run detailed tests on the sand and stone the aggregates, things like gradation, absorption, specific gravity, making sure those raw materials meet quality standards before they even go into a trial mix.
Okay, so checking the components.
Right. And you'll also have other Lab Level 2 certified technicians involved during the trial batching itself in the lab. They oversee or perform other specific tests on the fresh or hardened concrete samples generated during the mix design development.
So different levels of certification for different testing roles.
Yes, these certifications signify specific competencies in different types of lab testing. It adds layers of quality control to the whole mix design process.
Makes sense. And our sources mention some other, maybe more specialized tests that labs might run, but that don't always end up on the TR3.
Correct. Depending on the project's needs, the lab might do extra tests during development.
Like what, for example?
Maybe chloride ion resistance testing. Very important for bridges or parking garages exposed to de-icing salts. Or shrinkage testing, to predict how much the concrete might shrink over time, which relates to cracking potential.
Uh-huh.
Sometimes split tensile strength. which gives an idea of its resistance to splitting apart under tension. These provide deeper performance insights, but aren't always mandatory fields on the standard TR3.
Got it. Extra data for specific situations.
Exactly.
So if we were to sum it all up, the whole TR3 process in New York City seems built around a really clear division of labor and accountability.
Absolutely. The testing lab does the science part. The design, the testing, generating the mixed design, filling the TR3, that's their core function.
But they're not the only ones responsible.
Not at all. The system requires those other signatures. The architect or engineer confirms it fits the design. The producer confirms they can make it with the right stuff. The applicant initiates. The owner acknowledges.
It's a multi-layered check. Everyone has skin in the game, so to speak.
That's the idea, to ensure everyone's aligned and accountable right from the very beginning.
And understanding this initial phase, the mixed design development and the TR3 approval, it really does feel fundamental for any concrete project in the city. Get this wrong, and everything that follows is built on a shaky foundation.
It truly is the groundwork.
Yeah.
Everything else, the site inspections, the field testing under TR2, the final strength results, it all traces back to this initial approved design documented on the TR3.
It really makes you think, doesn't it, how that upfront rigor, that whole process we just discussed, how it sets the standard, how it fundamentally impacts the quality, the safety, the longevity of literally every concrete structure being built. The skyline itself depends on getting this right.
That's a powerful way to look at it, and it's absolutely true. The integrity of the city structures starts right there, with that approved mixed design of the TR3.
Definitely something to consider next time you see a concrete truck rolling by. For those listening who want to know more, exploring the TR2 process or the different technician certifications could be a next step.
Good suggestion.
But for today, this has been a fascinating look into the TR3. Thanks so much for breaking down this vital piece of NYC construction.
My pleasure. It's a complex but crucial system.